Alrighty, welcome to lesson 7. Now we're coming along in our unit 2 journey. Last lesson we talked about our equivalent equations and what those represent. And today we're really going to explore a little bit further into what we talked about yesterday, right? What are the steps for writing equivalent equations? What operations what algebraic moves or operations do I do that can create equivalent equations and may not create equivalent equations? And so our learning objective today is I can explain why some algebraic moves create equivalent equations, but some do not. And so our vocabulary for this week is some review from elementary school and middle school, right? Distributed property and community property. I will be using that during this video, so it's important that you know what those two properties are and what they represent. So that is your vocab for today. Alrighty, let's get into it. So another activity that we do as part of our word map activities is a math talk. And so when it comes to a math talk, you're given usually 4 expressions or 4 options, and you follow those directions. And so, for example, take a look at the 4 expressions on the left and think about how you would evaluate them, right? Write down some strategies you would use. Most of the problems tend to build on each other in some way. And so you want to start thinking about how are you solving or how are you going through the process? And so that's what math talk is really for. It's right, you talking through how you are solving your equations. And so, for example, here, first I value the expression by taking 1/2 of 30 because 0.5 is equal to 1/2. So 1/2 of 30 is 15. Then I notice that there's a connection because 1.5 is the same thing as 3/2, which is the same thing as 1/2 times 3. So I can start building these connections with each other. And so we have our first math talk, right? Take a look at your four expressions and see is 0 a solution to each of these equations, right? This is something that we talked about in lesson 4, right? What is a solution to the equation? And so I want you to take a look at the 4 options you have here and think through how are you solving them, right? What strategies did you use to solve the equation? I'm not necessarily asking for each of the answers. I'm just asking for how are you thinking through your process, right? That is the goal of what math talk is. And so for the second activity, we're going to work through pairing equivalent equations together. And so when you're doing that, pay close attention to the operations that you're using to find the equivalent equations. Right? What are you exactly doing in as you are figuring out whether equations are equivalent or not? For example, when you come up to the card sort, right, we have all of our cards together. I'll move them over so I have a little more room to write. And so let's say I have this one. And okay, I'm looking for something that is similar to it. And it seems that, okay, this is pretty similar to it. And so how are these related? So you can see that the left side of your equation is the same, right? We still have 5x on the left side, so nothing is done there. And so the question is, how are 3 minus x and negative x plus 3 related? And this goes back to our commutative property, right? Commutative property. When it comes to addition, when it comes to our subtraction and our multiplication, we can change how we write our numbers, right? It could be 3 minus x or negative x plus 3. You notice that the signs of the terms are still the same. This is negative, this is negative. This is positive, and 3 is still positive. And so you're not changing anything, you are just switching the sides. Think back to what you learned in elementary school. 2 plus 3, right? 2 plus 3 is the same thing as writing 3 plus 2, right? Nothing's switching, nothing's happening. You're just switching the order of the numbers. And so that's our commutative property. And so another one you could take a look at is, okay, I have something here that has a parentheses. And so this goes back to our distributive property, right? I can distribute 4 to both of these numbers, right? So I have 16 is equal to 9 times 4 minus x times 4. I can write that down. 9 times 4 is 36. X times 4 is just 4x. And so see if you see that anywhere in your cards, and then you can start matching them up, right? This was the distributive property that I just used here. I can distribute 4 to both 9 and negative x. Remember, your sign here is not changing because your 4 is positive. So then moving forward, right, practicing what equivalent equations look like, let's take a look at what happens when that is not true or you do some sort of accident. Remember, we talked about balance. You always want your equation to be in balance. So whatever you do to one side of your equation, you must do to the other side. And you can see that in the first one, right? When 9x equals 5x plus 4, so we have two expressions, one on the left side, one on the right side, and the result is 14x equals 4. And so if we assume these two expressions, 9x and 5x plus 4, equal, then if I am adding 5x to one side, right, as you can see from from 9 to 14, I'm adding 5x. If I'm adding 5x to one expression, but on this side, I'm not adding 5x, I seem to be subtracting 5x here, and subtracting 5x from the other side, then I'm going to create two unequal equations, right? What you do to one side, you must do to the other. It is a constant balance of equations, right? If I add 5x, then I must add 5x to the other side. If I subtract 5x, I must subtract 5x from the other side. And so see what you can do about the second part of that, right? Look at this expression. What are you doing here that creates a false equation? Right here, we added 5x on the left side, but subtracted 5x from the right side, and therefore the two expressions are unequal. And then moving forward, right, taking a look at what Noah's doing, right? So he wrote down a bunch of steps, and he was having some trouble solving two equations, and you work through each of the steps. So analyze Noah's work in each equation and moves that he made. So here's our original equation. He applied the commutative property, right? Commutative property just rewrote everything, putting the x's in order. And he combined his like terms. Remember, like terms are similar terms that can be combined. Like 3x and 1 are not like terms. And so we combined 4x minus 3 to get x plus 1, right? 4x minus 3x gives me x. And therefore, he subtracted x from both sides and got his answer. And so the question is, well, are those acceptable moves? And so I would say yes. All the moves that he made are absolutely acceptable, right? You can apply the commutative property. What he did to one side, he always did to the other. Rearranging when it comes to the commutative property, nothing changes. Therefore, you're always still in balance, right? So I would say all the moves that Noah made were acceptable, but he ended up with a false statement, right? 6 does not equal 1 as the end. So what is going on here? And so he ended up with a false statement. That means really there might be no value of x that makes the equation true. And you can see that when you look at the third line, right? Our third line here, x plus 6 equals x plus 1. Think about our understanding what numbers are, right? If I have x plus 6, right? If I have x plus 6 equal to x plus 1, there is no number that can make that equation true. And you could try to prove me wrong. Like, just try to pick up some examples. So if I have x equals 2, that means 2 plus 6 equals 2 plus 1. 6, 7, 8. 8 does not equal 3. If I choose 1, then I have 1 plus 6 equals 1 plus 1. 6, this is 7 is equal to 2, which is not true either. And so even though your steps might be correct, you have to take a look at the original equation. What is actually happening here? Is this true for everything? And so do 7, I will leave 7.3b for you, but take a look at each of the steps. What are they doing, right? And so one thing you want to keep in mind as well is what happens at the end here, right? If I have 2x equal to 3x, can I divide by x? Think about that as you are going through. Can you divide by x? And if you think the answer is yes, then is this all acceptable moves? Why do I have a false equation? So think through each of those steps. And last but not least, you have your lesson summary, and I will see you in lesson 8.